Good morning, friends. I am here again for my course Flight Mechanics. I am in the process of solving some problem. In this process, I will be taking some numericals on the topic problem solution on aerodynamic forces. I am Dr. Yagya Dutta Dwivedhi, professor from IARE Hyderabad. And in today's topic, I am going to discuss about determining the aerodynamic forces, determine lift and drag coefficients, determine engine thrust, determine air speed and the ground speed. So, in the numerical one, first I will be talking about first problem, that is aircraft Beech Baron 58 is cruising at sea level with a speed of 80 meter per second at 3° angle of attack. The wing area is 18.51 meter square and its aspect ratio is 7.2. Determine the aerodynamic forces, lift and drag. That is, this aircraft is producing, assume that the aircraft drag coefficient is 0.05 and the wing 0 lift angle of attack, that alpha 0 is equal to 0. So, here we have given some data. There the given data is speed of this aircraft. V is equal to 80 meter per second. Alpha, that is angle of attack, is 3°. Area S is equal to 18.51 meter square. Aspect ratio is equal to 7.2. CD is equal to 0.05 and alpha 0 is equal to 0. So now we know that we will start the solution of this problem. So since the wing airfoil is not given, we will assume theoretical lift coefficient shape slope, that is A naught is equal to 2 pi. So A is equal to CL alpha W, that is A naught divided by 1 plus A naught by pi aspect ratio. A naught is equal to 2 pi, 1 plus 2 pi divided by pi into aspect ratio is 7.2. So this A you will get 4.9 per radian. So this we got the A. From here we know that CLW is equal to CL alpha W minus alpha naught. So CLW, this we got 4.9 into 3.03 minus 0 divided by 57.3. So we will get here 0.22. This CL is approximately equal to CLW and that is the 0.22. So this we got the first thing. Now we will see here the lift coefficient, and we know that lift L is equal to half rho V square S CL 0.5 1.225 into 80 square into 4.5 into 0.22. You will get here that it is 15,963 Newton. And drag we can get half rho V square S CD. So 0.5 1.225 80 V square into 18.51 into 0.05, and here we will get this drag is equal to 3628 Newton. So this is the lift, this is the answer, and this is the answer. So we got these two answers, and here it is mentioned in this way. Now I will go for the problem number 2, and we will see here that an aircraft with a mass of 500 kg and a wing area of 8 meter square is flying at sea level at a constant speed of 50 meter per second. The aircraft engine is generating 600 Newton of thrust. Determine the lift coefficient and the drag coefficient. this flight, assuming the zero angle of attack, then determine the lift to drag ratio. So here, what are the things given? Mass is equal to 500 kg, area S is equal to 8 meter square, V is equal to 50 meter per second, T is equal to 600 Newton, alpha 0 is equal to 0. So weight is equal to mass into G. So 500 into 9.81, you will get 4905 Newton. And we know L is equal to half rho V square S CL. So CL is equal to 2L rho V square S, or L is equal to W. So 2W divided by rho V square S. So 2 into 4905, 1.225 into 50 square into 8. You will get CL 0.4. So we know that in addition, aircraft drag is equal to thrust. D is equal to T. So, and this is given as 600 Newton. So, we know that D is equal to half rho V square S CD. So, CD is equal to 2 into drag divided by rho V square S. 2 into 600 divided by 1.225. Velocity is 50 meter square and area is 50. So you will get 0.049. This is the coefficient of drag. So now lift to drag ratio, that is L by D or CL by CD. CL is 0.4 and 0.049. You will get 8.16. So this is the L by D ratio of this given aircraft. So these are the very simple problem which we have to understand in this way. Now if you see, we will go for the next problem. The aircraft in figure below is climbing. The aircraft in a figure below is climbing with a 15 degree of climb angle and a 5 degree of angle of attack. So gamma is 15 and alpha is 5. If the aircraft has a mass is 12,000 kg and the aircraft drag is 10,000 Newton, determine engine thrust and aircraft lift. So here this is the gamma and this is the alpha. So we have here given gamma is equal to 15 degree, alpha is equal to 5 degree, M is equal to 12,000 kg, D is equal to 10,000 Newton. So we have to find out the thrust. So we know that mass is equal, weight is equal to mass into gravity, 12,000 into 9.81. So 117689 Newton. We know that T cos alpha by the diagram D plus W sin gamma. So T is equal to D plus W sin of gamma divided by cos of alpha. So here we have this 10,000 drag, W we have just now 117689 into sin 15 degree divided by cos of 5 degree. So you will get this thrust is equal to 40622 Newton. So we got this answer. So now we have to find out the lift. So lift of aircraft. Lift of aircraft. So here we will see the lift. And we know this L plus T sin alpha is equal to W cos of gamma. So now lift is equal to minus T sin of alpha plus W cos of gamma. So minus 40622.7 into sine 5 degree plus W is equal to 12,000 into 9.81 into sine of cos of 15 degree. So we will get here 110,168.3 Newton. So this is the another answer of the lift. So in this case, although aircraft is in climbing, the lift is less than the aircraft weight. Okay, so this we have to always understand. So now we will go for the next problem, that is the problem number 4, and this we will see here that an aircraft is flying from city A to city B, from east to west, and then return back. The speed of the airplane, that is airspeed is 300 kilometers per hour. And these two cities are 600 kilometers apart. There is a wind that is blowing from the west to east and a speed of 40 kilometers per hour. Calculate the aircraft airspeed and the ground speed for both the aircraft. So in this we have to see that if there is a wind of 40 kilometers per hour blowing from city B towards the city A, the ground speed of the aircraft as it travels from A to B will be 260 kilometers per hour, and it will take 2.5 to reach B, but the airspeed will be 300 kilometers per hour. So net is 300 minus 40 is equal to 260 kilometers per hour. However, when the airplane flies back from city B to A, the ground speed of the return journey will be 340 because it will be added. So 340 kilometers per hour. The time to return the city A will be less than 2 hours, but the airspeed will still remain 300 kilometers per hour. That is, the wind will strike the airplane at the same speed as that of the outward speed. So if you see here, if both are in opposite direction, it will be minus, and if in the same direction, so 300 plus 40 and 300 minus 40 in this case. So to travel this, it will take more time and it will take less time. So we will see this problem. Numerical number 5, that is the fighter aircraft F-15 has a mass of this much kg and the wing area of this much. If this fighter is cruising at 15,000 meter altitude with the lift coefficient of 0.1, determine its true and equivalent airspeed in terms of knot. The air density at 15,000 meter is 0.1935. So here if you see, in cruising flight, the lift is equal to the weight. So L is equal to W, and it is given 30845 kg into 9.81. So 302589.9. And this lift is equal to here half rho V square SCL. From here we can find out the V. Putting all the value, we will get here 744 meter per second. In terms of knot, you divided by 0.145, you will get 1446.3 knot. The equivalent airspeed is equal to Vt is equal to Ves by under root gamma. So Ve is equal to this into 0.158. So you will get 574.9 knots equivalent airspeed. Same way, this we can do. Okay, this also. So this you can solve. These are the next problem. Determine the ROC of the climb angle, determine the rate of climb, determine the highest climb angle, determine the service ceiling. These are the references: Aircraft Performance and Design, International Edition, McGraw-Hill's first SL by ME Aircraft Performance Theory and Practice AIA Education Series AIA. Any questions, please do us to my email ydwedi@gmail.com. Thank you very much. Please do like and subscribe my channel.
Like, share and subscribe. Hit the bell icon for more updates.